what I want you to realize is that go to your formula sheet. Formula sheet shows you how, even if it's graphing. I want you to look at your formula sheet, and I want you to look at the very bottom right. So the very top formula on the right is the only one that was specifically stuck to chapter 4. It's that theta equals A over R formula, right? That's when you have those arc length ones with the arc, and you have to find it, the windshield wiper or stuff like that. All the rest of the formulas on here are used for sure in chapter 6. And then in chapter 5, there's these bottom two. These are the ones that aren't drawn to. So the chapter we're in right now, chapter 5, it's just the graphing of sine and cos graphs. This is the equation that the format that they give you. Okay? So, for example, sine is A sine B bracket x minus c plus d. And cos is A cos B x minus c plus d. So you can see this is the transformed form, right? Your vertical stretch, your reflection in the x, your horizontal stretch, your reflection in the y, horizontal translation, vertical translation. Yeah.
Why are we using C and D instead of H and K again?
Because they use C and D using sine and cosine graphs. Wait till you hear it. C and D are also not vertical and horizontal translations. In trig, they're called horizontal phase shift, because you're taking it and phase shifting it, and vertical displacement. You can't call it translation.
Okay.
And it's only in trig that it shifts. In exponents, logs, radicals, rationals, everything other than that, vertical translations, it is only in trig that it shifts to horizontal phase shift and vertical displacement. That's it. You're welcome. All right. I did not make trig. Okay. So we have y equals 2 cos x. So what I always do to make it so that I actually understand, because we're going to get to advanced ones with way more than just a 2 sitting in front, but that's fine. What I always do is I will fill in my A, my B, my C, and my D so I know what they are. Okay, and in grade 11, often your teacher would make you fill in your A, your H, and your K as well so that you knew if you had a 0 in somewhere, right? Now, if we look at these formulas, A and B are stretches. We agree? So what's the absolute minimum they could be if they're not there? If it's a stretch. 1, right? If you have no stretch, the very minimum A and B could be if they don't exist, like if there's not a number in their spot, it would be a 1, correct? You can't have a horizontal or vertical stretch of 0. That would mean that it would cancel it completely off. If I put a 0 here, the actual entire equation but the D cancels. And if I put a 0 in B, the entire equation but the inside of this cancels, right? It's gone. Your x is even gone. You don't even have a variable x. You just got rid of it. So if A doesn't exist and B don't exist, I can fill in 1s. Because they do exist. They're just a 1. But if C and D don't actually have any numbers, what are they? 0. Because I could have no horizontal translation and I could have no vertical translation, correct? But stretches have to be 1s. Do you see that? So when I go to write out the equation, if I want to help myself out, I can have 2 cos, and in brackets I could have a 1 for my B, x plus 0, this is going to look ridiculous, but it's fine, plus 0. So for A and B, if they're anything other than 1, stuff's happening. If for C and D, they're anything other than 0, stuff's happening. We agree? So what's the only thing that's happening for this one for transformations? Yeah. Yes. So we have a vertical stretch. By a factor of 2. About the x-axis. Now, can I short form that at all and cut some of it off? No. I have to write the whole thing. If you don't, you won't get the marks. Now, are there any other transformations? No. Now, let's think about it. Okay, we have a vertical stretch by a factor of 2. I take my graph. It's at -1 and 1, correct? Because it's at cos. It starts at 0, 1. Great. And now I vertically stretch it by 2. I'm taking it and I'm lengthening it by 2. We agree? What is changing out of all those options? Amplitude, range, period, domain, range, x-intercept, all stuff. Yeah?
The amplitude, the range, and the y-intercept.
Yes, the amplitude, the range, and the y-intercept. And the reason why is all those affect y's. We agree? So I'm taking my y-intercept from 0, 1. It's now becoming 0, 2, right? My range is now between 2 and -2, or -2 and 2, right? And my amplitude, instead of it being 1, is now 2, because my vertical stretch is my amplitude. We agree? So what's changing? My amplitude, my range, and my y-intercept. Now the amplitude, you guys did this yesterday, the amplitude is 2, because my vertical stretch is my amplitude. And the period, I said in degrees, so you can either do, there's two options, you can do 360 degrees divided by b, and b happens to be 1, so it's 360 degrees. Or you can say, okay, it's 360 degrees times the horizontal stretch. What's the horizontal stretch? 1, 360 degrees. Do you see how I do not care which version you get, other than that you get it correct? Yes. So either multiply by the horizontal stretch factor, or you divide by the b value, which is not the horizontal stretch, because period is not what the word is, it is period, right? So b is not the period, it is not the period, it is the period. And an equation, that's a period. I feel like a kindergarten teacher. Yes. Moving on. All right. What does this one have? Yes.
A horizontal stretch by a factor of 1/3 above the y.
Yes. And if I wanted to draw the whole thing out, I could go 1 sine 3 x plus 0 plus 0, right? So I have a horizontal stretch by a factor of 1/3 about the y-axis. Now, horizontal stretches affect the x. If you can't remember, it would be, your mapping would be xy becomes 1/3 x y, right? Because words in mapping are the same. They're in the heart, words in mapping. So what is affected by that 1/3? Yeah. The x-intercepts, the period. Does the domain actually affect it all in any of these instances? No, it's x0. So it'll just be the x-intercepts. They're going to change. They're going to shrink by 1/3, and the period is going to shrink by 1/3, right? So if the period is going to shrink by 1/3, and we're in radians, the period of every cosine sine graph, if there's nothing happening to it, is what in radians? 2 pi. If I'm shrinking it by 1/3, what's it going to be? 2 pi over 3, right? So if it makes sense to you, you will do better than if you memorize formulas. I trust in that in every way, because they tweak something a little bit. If you understand, you will be able to come out ahead than the person who's just memorizing a formula and hoping for the best. Okay? So the amplitude of this one is 1, because the vertical stretch is the same. The period is 2 pi. You could do both divided by b, which is 3. Or you could do the period is 2 pi times the horizontal stretch factor. And so it's 2 pi over 3. Either way, same answer. I do not care as long as you know what you're doing. Okay? All right. Now this one, once again, we have y equals 1 cos 1/2 x plus 0. Remember on your cumulative that your b always has to be taken out. You always have to have a what in front of x in order to state your transformations. You have to have a 1 in front of your x in order to state transformations, and that's where people get things wrong, because their horizontal translation will always be wrong, because they'll forget to take out the -1, or they'll forget to take out the number, correct? You have to have a positive 1 in front of your x before you start stating any translations, all year, and forever, till the end of time. Okay, 1 in front of an x. All right, so we have a horizontal stretch by a factor of who? About the y-axis. If I did mapping, it'd be xy becomes 2xy. Remember the numbers you have in words are the numbers you're going to have in mapping. Mapping in words is just the same way of expressing, a different way of expressing the same thing. And once again, the period's going to change, and the x-intercepts. This time, my graph is going to repeat. It's going to take longer to repeat than normal, correct? Because normally the period is 360, while I'm stretching it by a factor of 2. So instead of it being 360, it's now going to take till 720, right? I'm taking it and I'm like, I want to double that period. I want to stretch it by 2, because it's by a factor of 2. That's why when you say horizontally stretch by a factor of 2, because you're taking it and you're stretching it by a factor of 2. By a factor of 2 means multiplication. So we can either do 360 degrees divided by the b, and the b is a half, and we divide by a half, so multiplying by 2. So I get 720. Or I can use my horizontal stretch knowledge, and I can say I have 360, and I'm stretching it by a factor of 2, so I'm multiplying by 2. So now it's going to happen every 720. And my amplitude is equal to my vertical stretch, which is a what? Okay, we have a little summary here. The summary, the period of sine theta is what? Basic sine theta. Or 360 degrees, yeah. And cos is the same, because cos and sine graphs are literally just a pi over 2 shift of being each other. We agree? If I shift pi over 2, I can actually make each of the graphs. The parameter b in this equation, y equals f of bx, where f of x equals sine x, or f of x equals cos x, results in a what? Starts with an h. Nope. Close. Horizontal.
Horizontal phase shift.
Nope. Try again. A horizontal stretch. This means that b gives the number of cycles, right? So you can do 360 divided by b, or like I said, you can also just go 360 times the horizontal stretch, right? We would call it the same thing. And then we went to c. Here, I said to do this. We could also write these out to practice. We want 3 sine 2 x plus 0 plus 0. So my amplitude is equal to my vertical stretch. So my amplitude is 3. What's the horizontal stretch factor in this case? It's a 2. So the period, I could say 360 divided by that. And I get 180 degrees. Or I'm going to show the other way with radians. I could go 2 pi times my horizontal stretch. And my horizontal stretch is a half. So it's pi. Right? So you're either dividing by the b. Yep. Yeah. Why did I put 2? B equals 2. So depending on which one you're using, I put a half when I did it. Depending on which way you're doing it, if you're using the formula, b is 2. If you're using the horizontal stretch factor, it's a half. Yeah. This one, we have an amplitude of 2. We have a horizontal stretch factor of a third. Or I can say b equals 3. So if I'm using the formula, I can go 360 degrees divided by 3. And I get 120. Or if I'm using the stretch factor, I can say 2 pi, I'm doing it with radius, plus times a third. It's 2 pi over 3, which is 120. They're the same thing. So which method is better? One that gets you the right answer in your head. That's the one that's better. Okay? Either way, showing that on a diploma, if you picked either one, they're both completely correct. So whatever works best for your brain, you do. Okay? Is the amplitude -3 on this one? No, amplitude is always absolute value because it's always positive. Amplitude is a distance, and distance can't be negative, right? Displacement can be, but distance can't be. So my amplitude is 3. Also, my amplitude is equal to the vertical stretch, and the vertical stretch can never be negative, correct? That's a reflection. My horizontal stretch factor is 2, and my b is a half. So if I use the formula, like I do with the 360, I'm going to do 360 degrees divided by a half, which is 360 degrees times 2, which is 720 degrees. Or if I use the horizontal stretch factor, I'm going to go 2 pi times 2, which is 4 pi, which is 720. Both are good. This one, my amplitude's a half, so my period's actually shrinking, right? Instead of being 2 pi, my period would be pi, or instead of being 360, my period would be, oh, I'm sorry, I'm multiplying by 4. Why did I say half? The period's getting way bigger. It's going 360 times what? 4, which is 720 times 2, which is 1440. Okay. And then maybe 2 pi times 4, which is 8 pi. There are instances where people are like, I hate radians. There are instances when radians is just easier. Like 2 times 4 is 8. Like that is easier than 360 times 4. Trying to sell my radians. Okay. Radians are also the only thing that's good for word problems. Degrees make no sense. Because we're going to say that a wheel rotates in, say, 36 minutes, right? If it rotates in 36 minutes, is that degrees or radians? It has to be radians. In degrees, what does a wheel rotate in? What does a circle rotate in degrees? 360, does it not? How can you say that it would rotate in less than that in degrees? You can't. That's why word problems only make sense in radians. Because their standard of measure is going to be a decimal. It could be 12.1. It could be 14.7. It could be 96.2. It could be 1040. That would be an immensely large radian, but it could be. So whenever you do a word problem, it has to be in what? A trig word problem has to be in what? Radians. So those of you who come to the test is not, this test on Thursday does not contain this stuff, right? This is new, you now have been tested on, it's only on stuff you've been tested on. But when you come to the next test, and you go to do a word problem, and your answer is in degrees, and you say to me, Lepp, I didn't know it had to be in radians, I'm going to go back to October 25th podcast at 17:06, and I'm going to play this baby. And then I'm going to play the one for when we do written response, and when we do word problems, and I also tell you the same thing. Word problems have to be in radians. It's not an option. Just like the theta equals a over r have to be in what? Why did it have to be in radians? What are those questions? Word problems. Look at that. Riddle me this, Batman. They have to be in radians. Okay? All right. So we have a half. This one here, my horizontal stretch would be by 4, or the b would be 4. All right. State the period and the amplitude. Go. Period in degrees, radians. So the amplitude for this one equals the vertical stretch, which is 2. And then the period, I can either use the formula, which is 360 degrees, divided by b, and the b value is this. So I can either divide by the b value, or I can multiply by the horizontal stretch factor. Because dividing by b or multiplying by the horizontal stretch factor, which is the flipped, is actually the same math. Correct? You okay? You look like you're going away again.
I tend to do that.
Just disappeared for a few seconds. You're back. Okay. So we can either go 360 divided by the actual b value, which is 3, so you get 120, or you can do 360 degrees times the horizontal stretch factor, which is the flip of 3, so a third, and you get 120. Same answer. I don't care which version. You don't have to show both, right? Okay, this one, the amplitude is equal to the vertical stretch. Don't write amp. Well, you can write it in your notes. That's fine because they're your notes. But on a test, do not write amp. It's a standard of measurement, not amplitude. And the period is either 2 pi divided by the absolute value of b, or 2 pi times the horizontal stretch factor. So if I use the first one, that should be an absolute value. I don't know why I did the bracket. It would be 2 pi divided by a half, which is 4 pi. Or I can go 2 pi times the horizontal stretch factor. If that's a half, the horizontal stretch factor is 2. Ultimately, in the end, both of these methods make you multiply by 2, correct? So it doesn't matter which one you do. Okay, we're going to flip ahead to example 4. We're bypassing 2 pages, sorry, but we are. seems I didn't print them. Awesome. Or something. Where are they? Why you don't exist? Start where we're at. So, amplitude. You can either count the min to the max and divide by 2. So if I go from negative 3 to 3, that's a distance of 6. So my amplitude would be 6 divided by 2, which is 3. If you're someone who doesn't like that and you like the formula, totally fine. But on a test, you're not going to write amp. It's the absolute value of the max minus the min divided by 2. Now, if you're like, hey, am I given that formula? Are you given the formula? No. So if you choose to use that formula, that's when you're going to have to memorize. Okay? So it's the absolute value of 3 minus negative 3 divided by 2, which is 3. Either way, same answer. Do I care which way you go? No. I just care that you get it right. Okay? Now our amplitude is the same as our what? On an equation. The vertical stretch. So, this is a sine graph, correct? Remember yesterday when we looked at a sine graph? When we looked at a sine graph, it went through 0, 0, and then it went a positive slope up, right? And half the graph was here. Where's this graph? It's at 0, 0, and it's going upwards. So it's still a positive sine graph. What do you think is going to happen when you have a negative sine graph? It's going to reflect it. So it's going to actually just do the complete opposite. It's actually going to go downwards. It's going to have a negative slope right off the hop. Okay? Does this one have a negative slope? No. Now keep in mind, guys, that your amplitude gets you your vertical stretch, but it doesn't tell you if it's a reflection or not, correct? Because your vertical stretch could be positive or negative. Not your vertical stretch, sorry. Your A value could be positive or negative, but your vertical stretch will always be positive, right? So the amplitude gets you the A, but what it doesn't get you is if the A is positive or negative. Your brain has to get that. So we're going upwards, so that's a positive sign. Not a positive sign like, yay, it's really great today. It's a positive sign graph. Yes, sorry, A is positive. So I know that my equation is going to be y equals 3, positive 3. You don't have to write the positive, but I'm proving a point. Sine. Now, period. Do you agree? Is that even a word in the English language? I don't think so. Google it. But period. What it is not, even if it is a word in the English language, is the word period. See how that works? Period, not the same. So if I want to figure out the period of a graph is how long it takes to repeat. So you could go from a max to a max horizontally and see how much it takes you, correct? Or you go from a min to a min horizontally and see how much it takes you, correct? I always like starting on the x-axis, or sorry, the y-axis first and just seeing how long that takes me. But you could go from here to here and it would be 45 to 225 and figure that out as well, right? Because that's how long a max to a max would take you horizontally. You would go 225 minus 45, get an answer, yes? Or like I like doing, I like trying from the y-axis first. So I go past a max, past a min, back up to here, and how long did it take me? 180. But from a max to a max, 225 minus 45, 180. Or I can go a min to a min. It would be 180. Either way, it's 180. What if you can only see from a min to a max on a graph? Because sometimes they do that. Sometimes the graph is such a large period that they only give you a graph where you can see a min to a max. Yeah? You just double it. That's it. So max to a max is a period, a min to a min is a period. A max to a min or a min to a max is half of a period. So find out how long that takes, times it by 2. Right? Exactly. So we know the period is 180. So then blatantly, obviously, I can put that in for B because period is a period. Right? Yeah. Period is not a period. Period is a period, which starts with a P. So can I put it in, oh, P equals 180. Okay, cool. I can put it for B. If P equals 180, is that B?
Well, if you turn upside down.
You turn it upside down, still, yeah, okay. If you turn the key upside down, I don't know why I have to physically do it to realize that, but yes. But no. Okay. Period is not B. But we can think about this as a horizontal stretch factor, or we can use the formula, correct? So let's think about it as a horizontal stretch factor first. If it's 180, what is a normal sine graph? 360. It's now 180. So I shrunk it. So what's my horizontal stretch factor then? 1/2. So I know I have a horizontal stretch of 1/2. An aggressively thick marker. That's what I know I have right now. So I have a horizontal stretch by 1/2. What is that in the equation? 2. We can do it that way. Or we can use the formula, correct? What is the formula? The formula is P equals 360. I don't know why I'm putting a bracket. I'm going to erase that. So it's 360 degrees divided by B. We agree? But I don't want P, I want B. Yes? So I can swap them. I can bring the B up by multiplication and the P down by division. So I can go 360 divided by B. I mean P. So P is 180. So 360 degrees divided by 180 degrees. The degrees cancel off, and I'm left with a 2, which is B. So do you have to use the horizontal stretch factor? No. Could you use the formula? Yes. It doesn't matter. But what you cannot do is put the period in for B. Or say B is the period. Correct? Because that's not a true statement. You have to think P. Oh, P equals this. I'm going to put in for B. Does that make any sense? In any world, in physics, would you ever, M equals this. I'm going to put in for F. You'd never do that in physics. You would never. You should. I hope you never do that, right? So if you get P equals 180, would you go put it in for a B? No. If you think about it logically like that, you'd be like, that's just stupid. But people do. They take the 180 and put it in for B. And it is equally as stupid as you thought by putting P in for B. Okay, so try and stop yourself. All right, we have the equation. Poof, done. Great. What about this one? What is my amplitude? I go from -2 to 2 is a distance of 4. Divided by 2 is 2. Or I can use the formula, max minus min. 2 minus -2, absolute value divided by 2 is 2. Either way, it's 2. Let's think about cos graphs. Remember, the reason why I can compare this directly to normal cos graphs is there's no horizontal shift on this, is there? I'm not moving this graph off of the y-axis, am I? Because look, there's no C, right? So I can compare this as a graph that's not shifted at all, because they're not letting me have a shift. Where does my graph normally start for a cos graph? 0 and 1 at the top. It often starts on its maximum, doesn't it? Where is this graph starting? In its minimum. What's this graph doing? It's reflecting in the x, so what's my A going to be? -2. You see how you can do that? Based off of knowledge. But only because this has no shifts. Now what's great about it is, say you put a +2 in. You're trying to make an equation to a graph, correct? What's the very last step you should always do before you walk away thinking you're all smart and brilliant and you got it right? Graph it. Because you're going to graph it and you're going to put your 2 in and it's going to be up here and you're going to be like, something is wrong. Hopefully you'll figure out it needs to be negative, right? Worst case scenario, you don't get something right away. When you plug it in, you're going to catch a mistake, right? So whenever you get an equation of a graph, I really hope your last step is to check it. Make sure your window is the exact same, right? So you're checking it. Obviously, your window isn't like a horribly long rectangle, so it won't look exactly the same as this one because it's a longer rectangle, but it's very similar, right? All right. So we have y equals -2 cos. And how do I get my period? Well, a max to a max. So a max to a max is a distance of 720 degrees. Say you don't want to go that route. Say you want to go a min to a max. A min to a max is a distance of 360, and then I times that by 2. Either way, I'll get my period, correct? So the period is 720. Or we can say P equals 720, and that is not B, so I can't go 720, right? Now I know the original is 360. It's been stretched by 2. So I know I have a horizontal stretch by a factor of 2. So I know I can go 1/2 theta. If you're someone who's like, I hate that method, don't do that method. Use the equation. The equation is period equals, and we're in degrees, so 360 divided by b. The b and the p switch. P equals 360, sorry, b equals 360 divided by p. P is 720. When I divide the degree symbols off, they go away, and I'm left with a factor of 1/2. Ah, b equals 1/2. Now can I put it in for b? Yes. Every physics equation would be like, yes, you can. I don't know why I go to physics, but I know there's a lot of formulas in physics, so I always hit up physics. Chemistry is the same. They ain't quite different. But physics is the most formulas, I think, out of all sciences. Chem has quite a few. Bio has even a couple, like population formulas.
They're weird formulas.
Very low key. Okay, that makes sense? We can check it. We can see that's right. Okay. This one just wants the period and the amplitude. So the period of this one, pass to max, pass to min, is 2 pi. The period is 2 pi. When the period is 2 pi, or the period is 360, you should throw a little party in your head. Party, party, party. Because my b is what? 1. Every single time it's 2 pi or 360, b is 1. B is not a problem. B is like the best thing it could ever be. It's just 1. Okay? And then the amplitude for this one is 0.5. The period of this one, I can go from a max to a max. Now some people say, well, if I can always go from a max to max, why don't I? Because sometimes your max and maxes don't actually land on nice numbers. Like sometimes your max and your max will land between like a 2 pi over 3 and a 4 pi over 3, and you don't know exactly what it is, right? So sometimes you're drawn to different ones. Anyways, this one goes from 0 to 2 pi over 3 horizontally, so the period is 2 pi over 3. And the amplitude from -1 to 1, so that's a distance of 2. So the amplitude is 2 divided by 2, which is 1. Like I said, I can short form P and amp because this is not an exam. If this was an exam, I would say the period equals. If you wanted to write P instead of period, you'd actually have to have a let statement. You'd have to go let P equals period, which completely defeats the purpose because now you're writing the word period and the P and then the P again. I would just write period personally, but you can write let statements. So if you short form anything, if you want to, like you're a rebel and you're like, I want a short form. The only way you can short form anything is if you put a let statement and say what that short form is. So if you're like, I want A to be amplitude, right? So I could go let A represent amplitude. Let A represent amplitude. Then for only that question, I could use an A the whole time instead of writing amplitude, and they can't do anything about it. Because you've let statemented that variable, and you've told them what it is. Okay? Does that make sense? I just write the word out. But if you want to be a rebel without a cause, go ahead. Okay. This one here, the period, I go from a max to a max. Well, it's between pi over 3 and 2 pi over 3. What would I do? How do I find the in-between? I give you 2 marks. Your marks are 97 and 50. How do I find the in-between, aka the average? Yeah. I believe in you.
What I did is I just took pi over 2 out of my unit circle because it's between pi over 3 and 2 pi over 3.
Rebel without a cause used his unit circle. Okay. If he wasn't a rebel without a cause, how could you, you're not wrong. What would you do? Add and divide by 2. If you want halfway. Rebel. All right. Not incorrect, but a rebel. Okay, so if we want halfway in between, we will add up and divide by 2. This one's nice because it's a common denominator. So I'm going to get 2 pi plus 1 pi is 3 pi over 3 divided by 2. 3 divided by 3 cancels, so it's pi over 2. Or you could look at your unit circle and know that they're directly between the 2 is pi over 2, which is completely correct.
But can we still use pi over pi 2 pi over 3 and pi over 3 if the graph doesn't go through them?
Can we use them if the graph doesn't go through them? Yes, because we know that this does. This, which is what I care about, is halfway between here and here. You know what I'm saying?
Yeah.
Because I'm looking for that line, that tip. Not actually, I don't give a crap about where the graph is going through on these stuff. So the period is a half. Now, if that is rough, could we not find 2 repetitions and then figure it out? So we could have went like this. I could have went, okay, that's 1 period, and that's 2 periods. 2 periods takes me to pi. So what's 1 period? Pi divided by 2. I could have done that as well, right? So in many ways, you can do it as long as it's right. I don't care which way you go. And then the amplitude is 2. Oh my gosh. It doesn't matter it senses me. Not even joking. It literally does. That's why it's doing this. It's like sensing my arm. I figured it out. It's ridiculous. I need a longer arm. This board is arm sensitive. Like it's so how can I find the period of this one? So if I follow along here, I went past a max. Have I went past a min yet? No, so I would be like, shoo, and then, period. When did it happen? 6 pi, right? Sorry. And now because this and this occurred, that's when I know that I found half the period, right? Because I went past the max, back halfway, right? So then this would be half the what? That would actually be the amplitude. Because I would down here. So this here is actually the amplitude. So it's 1.5. I'm giving you just a couple questions. So that tonight you can also still do what? Study for cumulative. Okay. So it's this page, but it's not aggressively this many numbers. So, page 233. You don't have to sketch at 4 C and D, just so you know. I just want the amplitude and period. 6, your matching graphs. Something stacked with this paper.